Hello, ladies and gentlemen. Welcome back. I hope you are all doing well. Um, this video, I'm actually going to break into two different parts. So when you download the blank notes section, which I will get out there for you, you'll notice that it's a very long slide deck. I'm actually going to break the video into two parts, both of which are designed to help you review for the quiz on Wednesday. I'd probably recommend watching them both on Monday, but I also know that it would be pretty long just to watch it all the way through. So take a look at the video. Excuse me. Watch the first part, maybe work on some of the problems, come back to it maybe a little bit later in the day, watch the second part, work on some problems, or even break it up over Monday and Tuesday. I just want to make sure you have plenty of time to be able to practice. Also, I want to make sure that you all have time to see what you don't know, what you do have questions on, so you can take advantage of my office hours on both Monday and Tuesday if you need to, leading up to our quiz. So with that, why don't I kick it off? We're just going to kind of reorient ourselves to where we've been, get the quiz, and then we'll move on to something new on Thursday and Friday. So here we go. All right. When we last spoke, we were talking about parabolas. And we talked about how there are parabolas that go up and down, right? Like these home runs, this home run chart. These are all parabolas, right? Because gravity acts as a parabola. We can also look at a football that's been punted. You know, a higher angle, it'll go up and it'll come back down, might not go as far. A lower parabola will go a little farther, but won't get up as high. But that's examples of parabolas in everyday life. I also pulled this chart about how our own coronavirus is spreading, and I even mentioned this. Now you'll notice these aren't perfect parabolas, right? They aren't perfect. They're kind of only half a parabola, but you can see the way that a parabola moves is very similar to how a disease spreads. We've got a line that comes out and then it starts to curve up, right? This is not a line like you guys have been studying in algebra or even earlier this year. This is not a regular line. This is always going to act as a curve, and we talked about that a little bit. It's because one person doesn't give it to one person who gives it to one more person who gives it to one more. It spreads faster. It's like one person maybe gives it to three people, right? Let me go back. 1, 2, 3, and then those 3 people give a disease to 3 more people. So now we have 9, and then those 9 people give it to 3 more. So now we have 27, and all of a sudden this thing grows a lot faster. Now that's not exact for the coronavirus. I don't know the statistics behind that, but that is why all diseases, when they spread, go in a parabolic form like that. So just to kind of reorient ourselves. All right, so what we were looking at are just some specific parts of this. So let's go back here. This was day 1 with Miss Robaum, probably about 2, maybe even 3 weeks ago, I suppose now, and just identifying there are certain parts that we are going to want to talk about, okay? Well, the first part that we're going to talk about is this spot right down here at the bottom, right? This point where this particular parabola has been going down, now it is shifting and turning back up. That is our vertex. The vertex of our parabola is the point where if it goes up and then down, it's the point where it stops going up and starts coming back down. For one that is like this, it's going down and it turns and goes back up. That's our vertex. This line here that goes right down the middle of our parabola and cuts it exactly in half, that is our axis of symmetry, okay? Our axis of symmetry is the thing that cuts it right in half. And what does symmetry mean? It means the same on both sides, which is exactly what this does. It just cuts it in half, and it looks like the reflection over a mirror. All right, the next term that we want to look at is our y-intercept. And just like when we were talking about lines, or just like when you were talking about other functions earlier this year, we know we have an x-axis that runs left and right. We have a y-axis that runs up and down. The point where our function hits that y-axis, right? Here's our y-axis running up and down. The point where it hits that is called our y-intercept. And last but not least, we have our x-intercepts. Again, here's our x-axis. The points in here, there can be 2, 2 points where our function hits the x-axis. These are our 2 x-intercepts. Okay, and if you're given a drawing, you can find these points, right? You can find the vertex by looking for the point that's either all the way at the bottom or all the way at the top. You can find your y-intercept by looking along the y-axis, finding the point where it hits. Find your x by looking along the x-axis. Find the 2 points. It can be 0, 1, or 2 points that it will hit. And then the axis of symmetry, we always know, is going to run right down the middle of our chart. All right, so now what if we don't have a graph? What if we are just dealing with an equation? And I put the graph here so we can visually see it, but we don't need the graph. First, the easiest place to start is trying to find our axis of symmetry. Okay, our axis of symmetry, that line that cuts our graph right in half, we can find with x equals negative b over 2 times a. And let me make this a little bit bigger for myself. Negative b over 2 times a. Well, what do the b and the a mean again? Remember, if we are in standard form for a quadratic equation, where it goes sum number a times x squared, sum number b times x, sum number c, right? We put them in order. The x squared is the biggest, then the x, and then the one without an x. So we put them in that order, and we get a, b, and c. Okay? A, B, and C are constants. It shouldn't say not equal to the 0 because they could be equal to 0. Don't worry about that part right now. Those are constant. What's a constant? It's just a regular number, positive or negative. Okay, so to find that axis of symmetry, I want negative b over 2 times a. Okay, so looking at the equation, the example equation I have here, a is 1 because there's nothing there, so a is 1. B is negative 2 because that's the number that's attached to my x. And c is negative 8 because that's that last number that's hanging out there without an x. So b is negative 2, c is negative 8. All right, well, I'm just going to plug it in. Negative a negative 2, right? Because b is negative 2, and I want the negative of b. A negative negative 2 equals a positive 2. Over 2 times a. A, looking back over here, is 1. So 2 times 1 is 2. 2 over 2 simplifies down to 1. And I always put the x equals in front of my answer because that's what the equation of this line is. X equals 1. So if I'm talking about an axis of symmetry, x equals 1. X equals 2. X equals negative 6. X equals negative 1/2. Something, but it's always going to be x equals. All right, so that's our axis of symmetry. Perfect place to start when you're looking at an equation like this. All right, the next place to go is finding our vertex, okay? Finding our vertex is something we can now do after we find our axis of symmetry, okay? Remember, this point right here, the smallest point on this graph, right? The point where it was going down and now it turns and starts going back up, that point is called our vertex. Well, since this thing cuts our graph exactly in half, since our axis of symmetry cuts our graph exactly in half, well, we know our axis of symmetry will go right through our vertex. So we've got the x part of our vertex. Now we need to find the y part of our vertex. And to do that, we take our equation. We now know that x is equal to 1. So we take our equation and we plug in a 1 every time we see an x. Y equals x squared, so 1 squared, minus 2x, so 2 times 1, minus 8. All right, 1 squared is 1. Negative 2 times 1, minus 2, minus 8. So we get y is equal to negative 9. So here is what we would write as our answer for our vertex. Our vertex is at a point on our coordinate plane, and it is the 1 from our x, right there, and then negative 9 of our y go there and there. Okay? And remember now, since this is where our graph turns around, this is going to be either a minimum or a maximum value. Okay, so here's our vertex. Is that a minimum or a maximum? Well, every other point on this graph is above that point, right? This is where it comes down, it's going down, and then now it turns and moves back up. So this is going to be a minimum because it's the smallest possible point I could get on this graph. If my graph was flipped upside down and my vertex was up here, that's what a maximum would look like. Here, since our graph points upward, it's going to be a minimum. And what is that minimum? Well, we just take it right from that y spot, negative 9. This graph will not go lower than negative 9, so negative 9 is its minimum. Okay? All right, now we have found the axis of symmetry. We found the vertex. The easiest one is our y-intercept. Our y-intercept, to remember, is this point right here where our graph is going to hit the y-axis. All right, well, anytime I graph something and it's on the y-axis, anytime I graph something that's directly on this line, I know that x equals 0. Why does x equal 0? Well, because if I'm talking about this point or this point or this point down here, every single time I haven't moved left or right? When we're talking about a coordinate and I say move x to the left or right and then up or down y, well, if I'm directly on the y-axis, I didn't move left or right. So I always know anytime I'm talking about a y-intercept, x must be equal to 0. So take my equation again, plug in 0 for x, 0 squared minus 2 times 0 minus 8, and we get negative 8. Well, there's a shortcut. We don't even need to think through it that whole process. It is just c. Our y-intercept is always just that number that's hanging out at the end without an x. Don't be fooled. If you got an equation that looked like f of x is equal to x squared minus 3x, and that was it, your y-intercept is not negative 3 because there's just nothing out here. We want to look for that number at the end that doesn't have an x. Here, if I don't have anything behind that, that just means that my y-intercept is going to be 0. All right, but back to this one. Our y-intercept is at negative 8. That means I can write it as, well, the coordinate over 0, down negative 8, down 8, or I can just write my y-intercept is negative 8. Either one will work for me. Okay, let's check out the x-intercepts. Now, the x-intercepts, we need to figure out, well, since the y-intercept happened when that x was 0, the x-intercepts, notice how they don't go up or down. So that must mean that our y is equal to 0. Well, that one's not quite as easy to solve, but we can do it. I know you guys can do it because you've done it before. So we take our equation and we want to know, okay, so this all equals y. We want to know what happens when y is equal to 0. So if we set this whole equation equal to 0, all right, well, that's where we start to have to factor. And here, and we'll get to factoring a little bit later in the video, but because there's not a number in front of my x, I'm just going to use my regular cross. A times c, that's 1 times negative 8. B is right here in the middle, so that's negative 2. I'm going to pull this out over here. 1 times 8 would work. 2 times 4 would work. 3 is not going to work, and once I hit 4, I know I'm good. Okay, so how can I get these to be negative 2? Well, I know I have a negative out here, so one's positive, one's negative, and that must be negative 4 and positive 2. Double check it. These two multiplied by each other, negative 8. These two added to each other, you get negative 2. Perfect. So, factored form of this equation then, x minus 4, x plus 2. And if you need a reminder where we got those numbers, well, here's where the negative 4 comes in, and here's where the positive 2 comes in. Okay, last step. I want to set each of these things equal to 0 and solve for x. So x minus 4 is equal to 0. X plus 2 is equal to 0. Add 4 to both sides. X is equal to positive 4. Subtract 2 from both sides. X is equal to negative 2. So our x-intercepts are at negative 2 and 4. Okay? So that's how we found our x-intercepts. Okay, last thing we want to talk about in this portion of the video is domain and range. Okay, domain and range, and I'm using the exact same formula. Domain is all about x's. Okay, all about the x's. So I put a purple line here. It means what x's can we use? Well, here's the easiest part about these parabola equations. I can pick any x I want to, all the way out in this direction, all the way out in that direction. I could pick x equals 0 and I would find a point. I could pick x equals 4 and I find a point. I could pick x equals 1,000,000 and I would be able to find the y-coordinate that goes with it. So the domain on all of these functions is just that fancy real, or the fancy R, meaning all reals. I can pick any x value and it will work on this equation. Now, our y, or our range, isn't always that simple, but it's pretty easy to spot when you're looking at the graph. Remember earlier when we talked about the vertex of this thing and we found that our minimum was negative 9, okay? The minimum was negative 9. Well, since range deals all with y's, we're going to have some equation where y, and then we'll have some sort of operation in the middle, and then you can just plug in either your minimum or your maximum value, okay? Well, let's just ask ourselves, the y's that I get to use, do I get to, if I'm looking at this graph, right, it swoops down, swoops back up, which y values do I have? Do I have the y values that are above this line, that are greater than that line, or do I have the y values that are less than this line or below this line? Well, I've got the ones that are above the line, right? My graph goes above the line. So I get all the y's that are greater than or equal to my minimum negative 9, okay? If this had been a maximum, right? If we had had a graph that went upside down, we would have been having something like y is less than or equal to, let's say this is at 2. Y is less than or equal to 2, right? Because we are looking at the values below the line, okay? That's how we figure out domain and range. All right, so that shifts us over to the next part of the video. I thought so, but I just thought I'd check there. Take a chance, run through some of the problems, work through some of those, maybe let yourself rest a little bit, come back,